Hello, everyone. In today's session, I want to go over the solution of linear equations using Gauss-Jordan elimination method, because that would help us when we solve 3D particle equilibrium in my other channel, the basic engineering. There we may encounter three equations in three unknowns, and if we don't have or we are not allowed to use a calculator, then in that case we have to find an easy method, and Gauss-Jordan is the most well-known and used method. So let's start with that. Let me switch the camera. Oops. Let's make the hover cam. Okay. So oh my God, I don't know why I clicked on this by error. Let me just zoom in so you can see it better. So before we discuss Gauss-Jordan, let's talk a little bit about linear equations. Linear equations, we learned before that if you want to plot a linear function, you get a straight line. And usually linear doesn't mean straight, because as I said, if it's in 3D, then you can get a bunch of like planes. The idea is there is no curvature in it. So there is no x squared, there is no e to the x, there is no sine x, there is no x times y. So you can see that that we can, if we are in 2D, so just you have two variables, right? You can encounter one of three cases. There's nothing else. You can have something that looks like that, x plus y equals 4. And for example, 2x minus y equals 2. Okay, these are two lines and they have different slopes. Notice that if you want to find the slope, you subtract x from the first, so you get negative x, meaning the slope is -1. You have a line that goes like that. Here, when you move the y there, the slope is 2, which is something like that. So these two lines will intersect. The intersection of two lines is called the solution. So the point of intersection, another word for it is a solution to the line or to the two lines. Notice that if we have just one function like y equals x squared or something, or even x plus y equals 4, and I ask you what is the solution, it really, for a straight line, it doesn't make sense. Nobody will understand what you're saying. But if we are in 2D or 3D, or I'm sorry, if you have a second degree function or a third degree or e to the x, and I ask you what is the solution, I mean, where does it cross the x-axis? Why is that? Why? Y is not that. Y is 0 at the x-axis. So it's as if I'm telling you x or y equals x squared and y equals 0. They intersect at 2 points, for example, or they touch and intersect at a single point, or they don't intersect at all. So solution usually means the point of intersection. If I give you only one function, so what does it intersect? It intersects, we mean the x-axis. Anyway, so let's put this apart and talk about that. So we know for sure these two lines will intersect, right? Because they have different slopes. So for a straight line, if they have different slopes, they have to intersect. And you can see that you don't need to find the slope. You can say the ratio, say, of the x coefficients is 1 to 2. Here it's 1 to -1. It's not the same, so they are not. Or here 1 and 1, x to y, and here is 2 to -1, x to y. So they are not the same, meaning they are not parallel. A second case would be if I want to trick you. So I tell you, oh yeah, x plus y is 4 and 2x plus 2y equals 8. And you say, if you don't realize and you try to draw them, you get the same line. Oh, yes, because if I divide the bottom equation by 2, I get the top one. So I just gave you one equation and I ask you to find values of x and y. That's impossible. Well, I shouldn't say impossible. It's so easy. You say, I can assume x is 0 and y would be 4. So 0 and 4 is a solution. 1 and 3 is a solution. 1.5 and 2.5 is a solution. 6 and -2 is a solution. There are infinitely many solutions. Here there is a unique solution. And guess what? If I take the same line, x plus y equals 4 and x plus y equals 3, how is that possible? How can x plus y equals 4 and at the same time equals 3? It can't. Meaning these two lines are parallel. Both of them have a slope of -1. One intersects the y at 4, one intersects the y at 3. So they are parallel line, no solution. Mathematicians call that system of equations. Do you know what they call it? Probably have heard the term before. It's called inconsistent system. Inconsistent, not consistent. So these two are consistent systems, but this one is inconsistent. And if you want to plot it, you will see two lines intersecting, the same line, two parallel lines, no solution. Okay, so where does Gauss-Jordan come into play? Gauss-Jordan starts by, first of all, writing these equations in what we call augmented form. So, for example, to write this system, I'm going to write it in a matrix. Okay, if you want to learn more about matrices, I will have few sessions later. But for now, just think about it as a bunch of numbers written within these two brackets. We write only the coefficients. So here, I'm writing this for you, but we don't write it, okay? I'm going to enter the coefficients of x here, 1, 2, 1, 2. The coefficient of y here, 1, -1. And then some people add a dotted line to tell you that these are only the left-hand side and that's the right-hand side, but you don't need to do that. 4, 2. So that's like a shorthand way of writing instead of keep writing x and y, and especially if it's more than two equations. You don't have to write the x and the y and the z all at every single line. You just write the coefficients and we understand what you're talking about. Likewise, this would be 1, 2, 1, 2, 4, 8, 1, 1, 1, 1, 4, 3. Two equations in two unknowns is trivial, so I'm not going to address that here. We are going to apply the Gauss-Jordan elimination method using a 3x3 matrix, because that usually takes time if you want to solve it without the Gauss-Jordan. But before doing that, like when you learn a new topic, you learn its vocab. What's the vocabulary used there? Like any new language. So here, in order to learn Gauss-Jordan, we need to learn something called the elementary row operations. Elementary row operations, or EROs for short. And there are only 3 of them, and one is very rarely used, so really there are 2. ERO1 says that you can multiply, and basically, please understand, when I say multiply, I mean multiply or divide, meaning I can multiply by a number greater than 1 or by a fraction less than 1. So multiplication is a generic word for both multiplication and division. You may multiply any row by a non-zero constant. You say, why would I need to do that? You learn later. You will see why. I will tell you why. So If I multiply the first row and make it 2, 2, 8, I didn't change anything, right? If I multiply that by -1 and make it -2, +1, -2, it's the same equation. So that doesn't change. You have to understand that these three operations don't change the system, meaning the solution, after applying any of those or all of them or some of them, won't change the solution. The solution at the end would be the same. Okay? Like here, for example, you see that I can get what? You get, so you can multiply the top by -2, for example, or just you don't need to do that. If I just add these two equations, you get 3x equals 6. So x equals y equals 2. We know that that's a solution, okay? But if I had multiplied this equation by 2x plus 2y equals 8, then 2 times 2 is 4, 2 times 2 is 4, and 4 plus 4 is 8. It doesn't change, right? We know that. What is the ERO number 2? This is rarely used, and you will see why. When will I need it? You can interchange any two rows. And you say, wow, why would I need to do that? Meaning, instead of telling me x plus y is 4 and 2x minus y is 2, you're going to give me, after I solve that, you will tell me, okay, I'm going to give you another problem. 2x minus y is 2 and x plus y is 4. I would say, you're crazy, right? So why would I do that? We'll see it when we take an example. And finally, the ERO number 3, that's the most important, and you have to pay attention when I discuss it later, okay? You can add, and again, when I say add, I mean add or subtract, because you can add a negative value or a negative. So you can add a multiple, meaning twice, 3 times, 1/2 time, -2 times. You can add a multiple of one row to another. And that's the most important and most used one. 3 elementary row operations. You can take any equation and multiplying by a non-zero constant. Be it positive or negative, greater than 1, less than 1, it doesn't matter. Any number. You can interchange any two rows. You put the first second and the second first. We'll see why we would need that. And finally, you can add. This is very important. I take one row, say multiply it by 4, and then add it to another row. And these 3 are only the 3 elementary row operations that you need. So let's take an example, break it down into steps, and see how we're going to apply that. And then I will tell you a trick. Suppose, that's not a trick, but how can you check your answer if you have a calculator and if you are allowed to use a calculator? So sometimes you are allowed to, well, it's an engineering course, so most likely you have a graphing calculator that you can use, but when it comes to solution, they may ask you, no, you have to show the steps. You cannot just use the calculator and say x equals y equals, right? So we'll see how we can make sure that no matter what happens, we'll always get the correct answer. Okay, so let's write an equation. Let's say x plus 2y minus 4z equals -4. And then 2x plus 5y minus 9z equals -10. And then 3x minus 2y plus 3z equals 11. Okay, and we want to solve these three equations in three unknowns using the Gauss-Jordan elimination method. So the first step we are going to do is to write this matrix in augmented form. 1, 2, 3, 2, 5, -2, -4, -9, 3, -4 again, -10, 11. Gauss-Jordan, maybe I didn't tell you here the goal of the Gauss-Jordan elimination method. So if I have a bunch of numbers here in like a 3 by 3 or even a 2 by 2, it doesn't matter. So I have some numbers here. The goal is to write it, to make it look like that. On the main diagonal, which we call that the main diagonal of a matrix, I need to have 1, 1, 1. And then in the rest of each column is full of zeros. And then on the right-hand side, I will have three numbers. Now, you see how we wrote this? X plus y equals 4. 2x minus y equals 2. So when I read that, I get x equals S1, y equals S2, and z equals S3. So I have the solution. This form is called the RREF. That's what we will be using in our calculator. Stands for Reduced Row Echelon Form. Don't worry about it now. But our goal is to use these EROs to change the equations into a simpler one that gives me the solution right away by just reading. Okay? So maybe I forgot to tell you that why we need the elementary row operation. So our goal is to end up with 1, 0, 0. I'm sorry, 1, 1, 1, 0, 0, 0, 0, 0, 0. And the right-hand side would be the answer. Now, notice that if this was a 0, I cannot start. You can only start if there is a number. When you start a new column, the diagonal entry is not a 0. If it's a 0, you cannot use the first or the third elementary operation, because if you multiply a row by a constant, it's still going to remain 0. So in order, the only way to do it at that case, so if that was a 0 to start, I will have to interchange two rows. Suppose after I'm done a little bit, I move to this column and the 5 had changed into a 0. Oh my God, I cannot do anything, so I have to switch the second and the third. So that's the only time you are going to use the elementary row operation number 2. Well, I shouldn't say the only time. You are allowed to use it if it simplifies things. Suppose I give you this equation on the top and this equation at the bottom, and you want the entry to be 1, and you say, oh, there is a 1 entry here, so let me switch these two rows. Yes, you can do that, but you are not forced to do it. You can do it, but you don't have to. You only have to if so the idea is I will start with the first column until it looks like 1, 0, 0. And then I'm going to move to the second column, make it 0, 1, 0, and then move to the last column and make it 0, 0, 1. Okay, there are different ways of doing it. I prefer this method. I'm going to show it to you because it's consistent and it doesn't let you fall into a vicious cycle where you will go and try to correct something you are messing another. So our goal is to make this 1, 0, 0. Okay, this is already 1. If it's not 1, I would use elementary row operation number 1. But if it's a 1, I don't need to do elementary row operation number 1. That's why I told you number 3 is the most important. This is rarely used, This would be at most used once in each column. So if I have a 3 by 3 matrix, I'm going to use this elementary operation number 1 at most 3 times. Here, we are not going to use it here, so at most 2 times. That's why it's not that important. The last one is the most important. But be careful. In order not to fall into the vicious cycle I was talking about, make it a habit that if you are in column 1, like where we are now, you are only allowed to add a multiple of row 1 to the others. When we move to column 2, you will only be allowed to add a multiple of row number 2 to the other columns. So the row that we mention here matches the column we are in. We are in column 1, so we can only add multiples of row 1 to rows 2 and 3. If it's not clear, I will make it extremely clear, crystal clear. I have a 2. I want this 2 to be a 0. Nobody can tell me, oh, subtract 2. No, I cannot. That's not algebra, right? I can multiply the top row by -2 and then add it to the bottom one. Remember, we only have 3 elementary row operation. We can multiply a row by a non-zero constant, non-zero. So I cannot multiply this row by 0. We said we can multiply it only by a non-zero constant. I can interchange 2 rows, and none of those would give me a 0. The only way you can get a 0 for the 2 is you subtract twice row 1. So I'm going to multiply row 1 by -2 and then add it to row 2. Let's see, first of all, how row 1 stays the same. We didn't touch it, right? Now I'm going to multiply these entries by -2 and add them. So 1 times -2 is -2, plus 2 is 0. That's how I created it, right? That's how I picked -2. 2 times -2 is -4, plus 5 is 1. I'm lucky. I have a 1 here, so I wouldn't need to do anything. So I'm not going to use the elementary row operation number 1 again. At most, I'm going to use it once. It's not a big deal, but I can see that now. Multiply this by -2, it becomes +8. Be careful. +8 minus 9 is -1. Multiply that by -2. +8 again. Minus 10 is -2. So I'm done with the second row. Now I move to the third row. I have a 3. Likewise, I will have to subtract 3 row 1. Why row 1? Because we are still in column 1. I cannot do anything else for the other 2 rows, 1 and 3, of course. So I'm going to multiply this by -3 is -3 plus 3 is 0. We knew that. Multiply that by -3, you get -6 minus 2 is -8. Multiply that by -3, you get +12 plus 3 is +15. Multiply that by -3, you get +12 again, plus 11 is 23. I'm done with column number 1. So I move to column number 2. This is already a 1, so I'm not going to touch it. This is a 2. I want this to be a 0 and that to be a 0. So in order to make that a 0, you have to multiply that, or you have to say subtract twice R1. R2, I'm sorry. Subtract twice R2, because we are in the second column. So, first of all, let's draw that again. We are in column 2 now. Notice, The first column will never change if you follow what I'm telling you. So we are already done with that. And then the second row stays the same, right? 1, -1, -2. I already have a 1. Now I'm going to multiply the second row by -2 and add it to the first. 1 times -2 is -2, plus 2 is 0. Exactly, that's why I picked -2. -1 times -2 is +2, minus 4 is -2. -2 times -2 is +4, minus 4 is 0. And then you go to the third row and you say, well, I have a -8, so I'm going to multiply that by +8. So I'm going to add 8R2. You see? Here I subtracted 2 because that was a +2. Here I add 8 because that was a -8. And then we say -8. I'm sorry, 8 times 1 is 8, minus 8 is 0. Yeah, that's why we picked the 8. 8 times -1 is -8, plus 15 is 7. 8 times -2 is -16, plus 23 is 7. I move to column number 3. Here the main diagonal entry was 1, so I didn't use elementary row operation number 1. Here it was 1, so I didn't use it. Here it is 7. Elementary row operation says you can multiply or divide any row by a non-zero constant. Here, I will divide the whole row by 7. Divide by 7. So what do I get? The first two columns are already done, so I'm not going to worry about them. And then I'm going to divide the third by 7. So the 7 divided by 7 is 1. 7 divided by 7 is 1. I'm sorry, this is a 0. Why did I write 1? 1, 0, 0, 0, 1, 0. And now you can see that I already found the answer for z. X, Y, Z. Z equals 1. I already know that. I read it from here. I have a -2 and I have a -1. So I'm going to add to row 3. And here I have a -1, so I'm going to add a row 3. Notice I'm going to use this row, not that row, because these were 7s. I had to make them 1 first. So I'm going to take this row, multiply it by 2. 2 times 1 is 2, minus 2 is 0. 2 times 1 is 2, plus 0 is 2. X is 2. Finally, I'm going to add R3 to R2. 1 minus 1 is 0. We knew that. 1 minus 2 is -1. So y equals -1. I solved the problem. Yeah, numbers can be more, tough with fractions and stuff, but the idea is the same. I didn't use elementary row operation number 1 except once, because when I moved to the next column, here and there, I had 1 in the main diagonal entries, so I didn't need it. Only there was a 7, not a 1, but it was easy to divide it by 7 and get 1, 1 instead of 7, 7. I never used elementary row operation number 2. I didn't need to. But if I had come here and there were like, this number was a 0 instead of 1, I would say, let's switch the second and the third and deal with that. Notice that the 0 would have changed because we would be either adding or subtracting something. So in the third, when we move to the third column, so that we never used it. But guess what? We use the elementary row operation number 3. 1, 2, 3, 4, 5, 6 times. 6 times we used ERO3. 1 time we used ERO1, and we never use ERO2. Now I'm going to show you how we can use our calculator to solve that. And once we solve it before we start the solution, meaning I need to know the answer ahead of time. I will go to matrix, excuse me, second and X inverse, and then go to edit. You have 3 columns. You go to edit. The first one is a 5 by 6 matrix. What does that mean? It means it has 5 rows and 6 columns. But mine has 3 rows and 4 columns. So I would select this and say, make this 3, enter, 4, enter. And then I'm going to enter these numbers. 1, 2, -4, -4. 2, 5, -9, -9, -10, sorry, -10. Let me check it. Enter. Yeah, -10. Then 3, -2, 3, 11. If you enter them correctly, so all the numbers, see, I didn't enter them correctly. This is a 3. I think I missed the top one. Yeah, I missed it. This is not 3. I missed 1, so it's -10. You have to check that you entered everything. 1, 2, 3, 2, 5, -2, -4, -9, 3, and -4, -10, +11. You quit. Okay? Go back to matrices. But this time, instead of going to edit, go to math. You can click the letter B if you want, meaning alpha B. Or probably scroll up is easier. If you scroll up, you go to B, it says RREF. Remember, I wrote here RREF, which is Reduced Row Echelon Form. Be careful, don't go to A that says REF. REF is row echelon form, not reduced row echelon form. You want to go to B, it would write RREF. RREF of what? You say of matrix A. My matrix was called matrix A, which is the first one selected. So I'm not going to do anything except say enter, close the parentheses, click enter, and you get the answer. X is 2, Y is -1, Z is 1. So I already have the answers in front of me. Now, when I mean, if you want to check your answer, every time you go through, for example, we went from this matrix to that matrix. So you can check these numbers. X is 2, -2 is 0, plus -4 equals -4. So the first row is correct. Second row is the Y, which you already have the answer. It's -1, which is Y, plus -1, because Z is +1. So -1 minus 1 is -2. Correct. Third one, I don't have an X, of course. Negative times negative is +8, plus 15 is 23. So it's correct. I did my math. I came here. X is 2. Z is 1. So 2 minus 2 is 0. Correct. Y, -1. Minus 1 is -2. Correct. Z is 1. 7 times 1 is 7. So I can check. So if I did any math error by entering this as a positive instead of a negative, I can catch it while I'm still working. So every time I finish a matrix, I check it out so I don't waste time till the end. Okay? I hope this was helpful. Again, if you have any questions or anything that's not clear, let me know and we can go over it again. I will go to the engineering and try to solve a problem that requires Gauss-Jordan. The one I used last time was a simple one. Okay, thank you very much and hope to see you soon. Bye. Oh, okay.